are doing operations with radicals, and they are super rad. Why? A radical is just basically like a square root, cube root, or any higher root. It's literally just this guy, the square root symbol. That is a radical. That's what's called a radical. Cool, right? An entire radical is when you just have a radical with a coefficient of 1, or like there's no number in front. So like, for example, just like square root 2, right? Because there's nothing in front of the square root. So it's just something underneath the radical. Whereas a mixed radical is kind of like the same idea as like a mixed fraction, where it's like you have a number or a coefficient in front that's not 1. So for example, like 2 root 2. That's a mixed radical. And we know that not all numbers can be perfectly square rooted or cube rooted or any other higher root, right? So the goal is, instead of having like gross, ugly decimals, especially repeating decimals, we're just gonna leave it as a nice simplified radical. We wanna simplify it as much as we can. How do we do that? We're gonna break it down into two numbers, like a multiplication statement, where one of them is square rootable. So like, for example, with 27, I need to break 27 down. I could break it down into potentially 9 times 3, right? 9 square rootable, right? So you could also write this as like square root 9 times square root 3. So you can separate it. Square root of 9 is just 3. So this is just going to be 3 root 3. Prettier, nicer. Yeah?
What?
Did you have a question? Oh, you had a hand. Is that okay? That's it. That's final answer. That's as far as we can go. That's as far, because I can't then square root 3, and I can't break down 3 into anything, so that is the most simplified it can be, right? What about 72? What can I break 72 down into? 9 and 3 for 72? 9 and 8? Does 9 and 8 work?
Yeah.
Yeah? So I can do 9 and 8. Same dealio. If you want to break it down into 2, the square root 9 times square root 8, which is then 3 root 8. Can I break 8 down into 1? Yeah, I could. What could I do, Theo? 2 and 4. 4 is a square rootable number, so we can go even further. So now in that case, because I'm like re-simplifying and going again, this is just going to be like 3 square root 4 times square root 2, which is then going to be, I'm going to have to make room here. 3 times 2 times square root 2, which is just 6. Right? So even if you don't pick the most simplified two numbers, like the highest it can go, you can keep going in the simplification process, right? Just always check, can I break this down further? Can it be broken into a multiplication statement where one number is square rootable? In this case, we could with 8, and then that's it. 2, I can't do anything with. So simplified, square root 72 goes to 6 square root 2. Was that a hiccup? Whoa. Okay, and then now we got to do 5 square root 27. So we said 9 and 3, right? If I've got a coefficient on the outside, it's the same thing of like, okay, I'm doing square root 9 times square root 3. So now this is just becoming 5 times 3 times root 3, which is going to give me 15 root 3. That's the end. Not scary, right?
Pretty.
Huh? You said not pretty?
Pretty scary.
Oh, pretty scary. No, not scary. Right? We can also do the reverse. 10 sips of cold water straight. That will get rid of it. Or, like, press on your diaphragm right here, like, really hard. Hiccups are your diaphragm seizing. Like, press really hard with your thumb. There you go. I cured her. It's the restart button if you ever have hiccups. Your diaphragm. Life hack. So then, okay, I'm going to do the reverse now. I have a mixed radical. I want to make it into an entire radical, so no coefficient in front. So I need to do some like backward stuff, right? So I've got 4 root 5. Now I have to basically like square this. Like, where did 4 come from? Square root of 4 squared times square root 5.
Why would you do square root of 4 squared?
Because it's the idea of like, what did we square root to get 4, which is 16?
Oh, okay.
Yeah. Because basically it's like we got 4, so what did we have to square root to get 4? We had to square root whatever 4 squared is, right? And then what is 16 times 5?
80.
Voila. I know it's not bad. Did it click? Was it their light bulb? Okay, same dealio. I have a negative, and then I need to know, okay, what do I need to square root to get 6? 36, or 6 squared, right?
That's negative.
But it's a negative 1 times the square root of it. So the negative is not going under the square root. Then it's an error or an imaginary number, which I've already told y'all. That's above my pay grade. That's grade 12 stuff. I'm not going there. So 36 times 3, which is what? 108? Voila. So keep this separate from the negative. We do not put the negative under the root. Is this okay here? Following? We're good? We're good back table? Girl, I got eyes on the back of my head. I can see. Okay. Last but not least, you tell me, what am I doing? How do I reverse? I gotta do, whoa.
Squared.
Square root of 2 squared times square root of 10. Square root of 40, baby. Exactly. Boom. How is that? On a rating scale of not hard to super hard. 8 super hard?
Oh, I thought it was the other way around. Like 2.
Perfect. Okay. So that's how we're going to flip. It's actually not going to get harder. That's literally like it, basically. Now we have some rules, because what if I want to start combining radicals, whether I'm multiplying them together or adding them together? We are going to treat this just like we do with variables, right? So for example, square root of A times square root of B is just going to be square root of A times B. So if there's 2 things under the radicals, we multiply them together, right? Versus if I've got coefficients and square roots, we're going to do like terms. So coefficients go with coefficients, square roots go with square roots. So this is going to be CD times A times B. That's it. So coefficients get multiplied to coefficients, radicals get multiplied with radicals. We don't crisscross, right? And obviously this is for A and B values greater than or equal to 0, because we said no negative numbers under the square root. We're not doing that.
Probably never gonna happen.
Maybe in grade 12, but not this course. Yeah. So, okay, if I do this one, what's happening here? I'm just going 5 times 11 under the square root, since they're both under a square root. And then this is square root 55. Can I simplify this? 5 and 10? Are either of those square rootable? 5 and 10?
No.
Or no? What? That's 50.
11 and 5.
11 and 5, are either of those square rootable? No? Can I do anything else? No? So that is the most simplified radical. If you cannot break it down into one square rootable term, can't do it. What about this one? If you want to use your colors, get your colors out.
Minus 8, square root of 36.
So negative 4 times 2, and then square root of 6 times 6. So this is going to give me negative 8 times the square root of 36. Let me throw in some equal signs to look professional. And then 36 is square rootable. That just gives me 6. So this is really just negative 8 times 6, which is type
Negative
40.
48.
Is it? Don't ask me. I don't know my times tables. I just tell people to memorize them. That's it. Okay, last one. What happens here? I don't have a coefficient in front, so what even is that? It's just 3 times 1, and then square root 7 times 12. Whoa.
Do you have to add the 1?
Multiplying. So 3 times 1. I think we definitely can. What can I write 84 as? One number has to be square rootable. One number has to
Write it as
be.
4 times 21.
4 times 21.
That does work.
Okay, and then square root of 4 is 2. If you don't want to keep writing these steps of like breaking it down, you could just go straight into square root of 4 is 2. So this is going to be 3 times 2. I'm just doing it for the lesson so people know like where I'm pulling these numbers from. So okay, I've got 6 square root 21. Can I break 21 down? Because I'm like 3 and 7, 1 and 21. I think that's it.
Yeah, it doesn't work.
Can't do anything more. That's all. Voila. That's multiplying. Easy. Adding and subtracting, this is where, no, I swear this is easy because you're just treating it like terms. Like for example, 2x plus 3x. Those are like terms, right? 2 root 2 plus 3 root 2 is just 5 root 2. So you're just treating the radical like it's a variable, and you're just adding the coefficients together or subtracting the coefficients together. That's all. So if they have the same radical, same square root, put the coefficients together, right? So they are considered like terms. That's what this was, like terms. Right? So even just looking at the first one, I've got 3 root 3 plus 8 root 2 minus 4 root 3 plus 11 root 2. These two have root 3s. And these two have root 2s. They are like terms. So really, I'm just doing, I want to go back to blue. And I'll rewrite this for, again, the extra steps of just seeing what I'm doing. I'm going to put the root 3s together and the root 2s together. So I'm just rearranging to have my stuff side by side. Okay, yeah?
With the negative sign, does that affect the square root number as well, or is
Nope.
that just the negative?
Just the coefficient. So first one, 3 minus 4. What is that? 3 minus 4? Negative 1. So negative root 3. And then 8 plus 11. 8 plus 11. 8 plus 11? Yes. 19 root 2. Done. The radicals do not change. They will only change if you need to like simplify them, for example. But in this case, when they're simplified, you don't do anything with them. We just added the coefficients. 3 minus 4, negative 1. 8 plus 11, 19. That's okay? Solid. What if I need to do some simplifying? Because at first look, I go, ew, they are not alike. I can't do anything with this. But like maybe I need to simplify them first. I can't? Why not?
It doesn't work too well.
Why? I can break down 8 into like
This
4
one.
and
I thought you were talking
2.
about the last question. That's what.
Right? And then what can I break 18 down into? Are either of those square rootable? 9 and 2. 9 square rootable. So now this is really just square root of 4 is 2, root 2, minus square root of 9 is 3, root 2. Well, would you look at that? They are the same. They are both square root 2. There is a turn of events. I know. Shocking. 2 minus 3? Negative 1, so negative root 2 is your final answer. No, I think he got it right. That was an excitement slap.
Yeah, that one.
Yeah, exactly. Right? Not bad. Not bad. Are we okay here? What? Tell me, what? The first one, I was just putting, so remember how we said like 2x and 3x, those are like terms because they have the same variable? We're doing the same thing but with radicals. So like square root 3 and square root 3. I can put those two together because they both have square root 3. So then I just added and subtracted the coefficients. So 3 minus 4 is negative 1. And then 8 and 11, they make 19. So you're just merging them based on like terms. Okay. Do you need time to copy this, or are you good? You're good? I'm good to go to the next page, because this is the end. This is you now just applying your knowledge of radicals. If I were to say, for example, here's a shape. All of the side lengths are ugly. They're all radicals. What is the simplified expression for the perimeter? How do I find perimeter? I add them all together. So P is going to be equal to square root 8 plus square root 18 plus square root 12 and then plus 2 root 3. If you'd like to simplify first and then add them, that's fine. If you'd like to just do it in this process, that's also cool. Like if you wanted to simplify them like on the diagram and be like, this is actually this simplified expression or that. It doesn't matter what process. So 8, what can I break that down to? 4 times 2. 18, I can break down to 9 and 2. 12, I can break down to 3 and 4. 4 is square rootable. And then 2 root 3, I can't do anything with. That's the end. Right? So when you're breaking down, one of those numbers has to be square rootable. You cannot pick a pair where neither of them are square rootable. One has to be. Right? So in this case, square root of 4 is 2. So this is 2 root 2. Square root of 9 is 3. So this is 3 square root 2. Square root of 4, we said is 2. So this is 2 root 3. And then 2 root 3. Now that I'm simplified all the way, can't go any further, I got to add my like terms, which they're already in order beautifully. So I've got 2 root 2 plus 3 root 2. That's going to give me what? 5 root 2.
4 root 6.
Why root 6?
No, root 3.
For 3, that's what I meant. So I really combine.
Radicals do not change when we're adding and subtracting. If we were multiplying, then it would be 9. It's not even 6. I tried to save you there. And that's it. So that's the expression for the perimeter. This is some gross repeating decimal number. This is way prettier. We want to keep it in this form because this is exact. Right? So all I did was add up all the side lengths, simplify the radicals, combine like terms. Done. What if I were giving you one that you have to FOIL? Remember our good friend foiling?
Yeah, don't try to do that.
First, outer, inner, last. So this is going to be 3 times 2, which is 6. 3 times square root 24, or 3 root 24. Negative root 6 times 2. What's that going to be? Minus 2 root 6, right? We can't combine them because it's not under the square root. And then negative square root 6 times root 24.
Negative 144, which is also 12.
It is a nice square rootable number. So, okay, if I go into simplifying this, how can I break up 24 or 1 square rootable?
6 and 4.
9 and
6 and 4.
6 and 4 I like. 6 and 4 I think works. And then can I do anything with 6?
no, but you can
No. And then I've got minus 144, which is actually just 12. It square roots perfectly. So, okay, now this is going to look like 6 plus square root of 4 is just 2. So now this is 2 root 6 minus 2 root 6 minus 12. What now? Yeah, like terms. What's happening with these two? Ciao. Bye. They cancel out. And then I'm just left because positive root 2 minus 2.
Hold on. Yeah, what happened to the 3 on the outside?
What 3? Ah!
Yeah,
I prematurely said goodbye.
yeah.
I prematurely said goodbye. So then this is
So that's 12, right?
this is 3 times 2, which is 6. Y'all, I got too excited. I left out the 3. Sorry, 3. See, thank you for correcting me. So then I can't cancel them out, but I can still add them together. So, okay, if you want to do constants first, like the numbers, like 6 minus 12, that's just going to be minus 6. And then 6 minus 2, 4. So 4 root 6. It does not matter if you put the 4 root 6 minus 6 or that, as long as their signs are correct.
Well, so you don't need to like make it like minus 2. 6 by like combining it 4 minus 6, right?
No, and you could also do 4 root 6 minus 6, like swap their places.
Yeah.
That's still equal, right? As long as their signs are correct.
Yeah.
Yeah. That's it. That's all I've got for you. So, today, peeps, like 2 more minutes, okay? 2 more minutes. I have questions for you to work on for the homework. You can also catch up on things that you've missed yesterday. I posted answer keys to the review stuff we did yesterday, except for the graphing stuff. I have to do the answer key for that. So if you'd like to also keep working on that, you can. And then I already told y'all about when we're going to do the assignment and stuff. Friday. Yeah. We did review. So it's all online, or I think all the sheets got snatched up. So it's just completing the square practice, graphing practice, and word problem practice. And I said, take what you want. Like, if you want to do word problem practice, do that. So it's all in the Google Classroom.
Can I go to the bathroom?
We
Also, when was it?